We're going to continue our discussion on expectation for discrete probability distributions and look at it from the perspective of insurance. A term life insurance policy will pay a beneficiary a certain sum of money upon the death of the policyholder. These policies have premiums, or payments, that must be paid annually by the policyholder. In these two situations, we have the same scenario, but we're going to look at it from two different perspectives. A 35-year-old woman purchases a $100,000 term life insurance policy for an annual payment of $360. Based on a period life table for the U.S. government, the probability she will survive the year is 0.999057. Find the expected value of the policy, first for the insurance company for 1 year, and then for the woman for 1 year. What this means is, when we talk about our random variable x, which is going to be the amount of money we get, who we is and how much we get will change whether we are the insurance company or we are the woman. Let's do the first one. So if the woman lives, she has a probability of 0.999057 of living. We're looking at this from the perspective of the insurance company. So we are receiving the payment of $360, and we would have to give away $100,000 if she died. So if she lives, what happens? We will get the $360 that she paid. So we get $360 that she paid. If she dies, the probability that she dies will be 1 minus that 0.999057. So we'll fill that in a second when we get our calculator out. But let's talk about the random variable now. Just like with our problems on the games, we would pay out $100,000. So we're losing $100,000, but also we get that $360 that she would pay. So the idea with these life insurance policies is they're not going to pay any money unless you've paid the first premium. Okay, so let's calculate these. I have 100,000, I'll make it negative, plus 360, and I get negative 99,640. And then for the probability, 1 minus 0.999057, and we get 0.000943. Once we have our probability distribution table, we can calculate our expected value. X times P of X plus X times P of X. 360 times 0.999057. We get a number, plus 99,640 will make negative, times 0.000943, and we get $265.70. So our expected value, on average, each year, the insurance company will make a profit of $265.70. on this one person. So think about if the company has a lot of these different policies, this is how the insurance company makes a profit. Let's turn the tables and look at the same situation but from the perspective of the woman. So from the perspective of the woman, what ultimately changes are the values for X. So if she lives, the probability stays the same. If she dies, the probability stays the same. But this time, we're looking at it from her perspective. If she lives, she pays $360. She loses it. But if she dies, her beneficiary will gain $100,000, and we're going to subtract off the $360 from the woman paying for the insurance, because that $360 would no longer be part of her estate. And if we do that, we'll get a positive 99,640, only the signs have changed. So here, in changing the perspective of our problem, the only things that change in our discrete probability distribution are the signs on X. And what does that mean for our expected value? Well, instead of positive 360, we have negative 360, and instead of negative 99,640, we have positive 99,640. And if we put those into our calculator, we'll get a negative 265.70, meaning that on average each year, the woman would lose this money if we were to repeat this process over and over and over again. Just by changing perspective, we change the sign on the expected value. But this is exactly how insurance companies make their money. Whether it's car insurance or homeowners insurance or renters insurance, they look at past data and empirical probabilities and then come up with rates for their policies that on average would allow them to earn money.